And take it away, Igor.
Yeah, hello, my name is Igor. Yeah, currently this will be a walkthrough video about GitLab SSHD and like a documentation that we have for all the information that we have and all the code, maybe not all the code base, but some of the code base that we have in GitLab shell project. Yeah, so we have a GitLab shell project that is written in Go language. Yeah, initially we had it written in Ruby, but maybe 3 years ago we've written it to Go language due to some performance reasons. And quite recently we've decided that it would be cool to have at first it was used as a OpenSSH server that handled all the SSH connections and a binary that was called for every SSH connection. But quite recently we've rewritten it, and now it's just a dedicated server that handles all the SSH connections by itself. So yeah, let me show you. So GitLab shell is a project, and we also have a package which is called SSHD that contains all the code. And this package actually responsible for handling the SSH connections. The reason why we implemented our own SSH solution, SSHD solution, can be found in a blog post that we've released quite recently. It contains all the information, how all the history, prehistory, all the opportunities, advantages that we wanted to gain with this dedicated SSHD server. And also it contained the previous architecture that I've described here, like the one that we have with OpenSSH. Let me maybe show you that before we had something like this, like OpenSSH server that was calling the GitLab shell as a binary. And currently we have like simplified architecture that we will return to it a bit later. And yeah, also this article contains risks and challenges, problems, and lessons that we've learned. Yeah, so let's have a look how it works, how it actually works now. We have GitLab SSHD server that handles all the SSH connections that a user performs. Maybe it's important to mention that GitLab supports some features that can be performed by SSH. For example, the most important one, I guess, it's like Git operations. When we perform Git archive, clone, pull, and push with SSH, yeah, it can be performed by HTTPS and can be performed by SSH. So when we see something like this, then yeah, we perform it with SSH as a SSH connection, as a SSH command. Some other commands can be also performed, but maybe let's keep it for now. So yeah, this package allows us to handle SSH connections. And yeah, so when a user, for example, performs a git clone, it's the same as performing SSH command with this command. It actually looks like this. So it returns some mysterious cryptic data, but actually Git knows how to handle all this one and how to communicate with Git client and Git server. So when this command is performed, GitLab SSHD actually handles this SSH connection by performing a handshake with a user, with the SSH client, and also with Rails by fetching authorized keys. And then when this command is performed, we also ask GitLab Rails whether the user is allowed to perform a particular command. And if this command is allowed, a request to Gitly is performed, and Gitly also handles the communication with Git on the server, and then user receives all the data that they requested. So how it actually works in the code base, we have an entry point, which is a main function. This is actually an entry point for a binary. This main function, the most important part here is that it creates a new server that is ready to listen for new connections and process them. This new server and listen and serve functions, they are implemented in the SSHD package, actually in this SSHD Go file. And let's have a look at those comments. So it just creates an instance of a struct and then just listens and serves the connection. Listen and serve works like this. It just calls like private functions, listen and serve, and listen looks like this. It's just create a TCP listener and listen for all the requests. But just a quick note, if something is not very clear, but I'm pretty sure that maybe it's not very clear, maybe you can either ask questions now, or maybe it can be skipped for now, because we have like this documentation. Sean?
Can I just say something, Igor? And sorry, I probably should have mentioned this earlier. I don't know how what everyone else has after this meeting, but if we need to go over, maybe we can go over so that you don't have to rush. So I don't know if other people have other meetings, but what I'm saying is feel free to take your time, and the same with questions, I guess. Yeah, it sounds great. So I don't have any meetings afterwards. So if you have any questions now, maybe we can discuss some of the parts of this code now, but maybe I can continue. What do you think? So the SSH requests, they are accepted by the listener, and then they are processed by the code that we have. Like handled, the connection is actually handled. The connection, it performs, it calls like this function, and actually perform the handshake between the server and an SSH client or a user. SSH perform handshake in order to negotiate the algorithm, the algorithms and cryptographic models that they are going to use in order to provide like a secure connection between a user and the client. During this handshake, we actually perform the request to GitLab Rails, the one that I mentioned before. Sean? Okay, just a quick question. So at the client end, we just have Git, right? We just have the normal Git binary that we haven't touched, of course, in any way. But gitlab-sshd is consuming all the Git protocols and then providing encryption or whatever that in a way that Git can understand. Would that be correct?
Actually, it's Git. Git performs like Git establishes the SSH connection. And actually, gitlab-sshd, it's just performs a handshake to establish a connection, an SSH connection. And so it's just an SSH connection, and then Git starts pushing or receiving the data. And it's actually, I would say, it's actually Gitly that deals with with Git protocol and all the data that is related to Git. gitlab-sshd, it's actually responsible only for handling the SSH connection and establish a connection with SSH protocol.
So by using a remote, which is an SSH remote, the Git binary somehow knows how to open an SSH connection, and which we accept with gitlab-sshd.
Yeah. Okay. And as I mentioned, Git is likely performing something like, I'm sorry for this debug messages.
That's great. Yeah.
So it performs something like this. This is actually an SSH command to my local host server on this port, and it just executes this command on the server and receives all the data. So so when the SSH handshake is performed, this request for authorized keys is performed to Rails in order to authenticate the user, because the user, it sends like it's a public key. Or maybe sorry, I'm not prepared. I won't try to show my own public keys. Or maybe I can. I forgot. Yeah, like this. So like this, the one that configured on gitlab.com. SSH like sends the public keys that that exist on the server, that exist locally. Also, that also exists locally. So SSH actually iterates over the keys that exists in this SSH folder, and performs a handshake and identify the user that is actually performing this request. So when a user is authenticated, we are ready to process the sessions. What does it mean? When a connection is established, a user can have multiple sessions. It's something that I learned, I would say, quite recently, that an SSH connection, it actually can be persisted, and by specifying these commands. So if we have a look, if we run our gitlab-sshd server and perform a simple SSH command to the server, we see that like authentication is performed, like algorithms are negotiated and connection is established. When we performed the same request one more time, we receive much less logs, and we see this line that mentions that multiplexing control connection. So this connection is reused, and so maybe it's not, we're not fully approving this stuff, because we have a long running SSH connections that are established to gitlab.com, so potentially it can be like a lot, but we had this behavior before with OpenSSH, and currently we don't see like performance issues caused by exactly this functionality. So we introduced it in order to be backward compatible. Now we don't see a lot like performance issues related to that, so we left it here. But maybe in the future we can like remove this functionality, because it doesn't seem very useful, because like Git, because of the specifics of the Git, we just perform a Git clone or Git push. Maybe it's not worth it to keep the SSH connection open. So this part, so we're ready to handle the sessions and ready to actually process them. This part is tricky because we forgot to refactor it, but this function is actually passed as a parameter. And let me see, handle like a parameter, and the actual implementation exists in other file, which is called like sshd go. Yeah, but we forgot to refactor this part, so apologize. This yeah, excuse me. I don't hear you.
Yeah, sorry, I've got another question. So this is something. See at the top of the screen, you've got a deferred function.
Deferred function, yeah,
right.
Here.
And then we've got this. Is this something similar to how it used to work in jQuery, where it's like, why we got this function and then it's followed by a pair of empty parens afterwards? What does that? I know that's a Golang issue, but what does it actually mean?
So yeah, it's
like line 187, for example.
Line 87, like
here,
yeah.
Calling the function.
It's calling the function. It's so it is the same as how jQuery used to do it.
Actually, I don't remember. This function is in jQuery, yeah, but in Go language, yeah. Since we have time, maybe let's discuss it. Like here. So it's like a simpler example. So defer function is just we just specify that we want to execute this code.
Yep.
After the function is completed.
Yep.
Yeah. When for example here we want to return execute this function at the end of this block. So we actually will receive like hello and then world. Yeah. Why don't we want to do it like this? Yeah, we could, but actually it's possible that we have something like this. Yeah, defer. Like here, yeah. So if, for example, we want to execute f every time the function is completed, yeah, after return a and after return b, defer will actually do it. It will execute this function after this return or after this return. Because if we didn't have this like syntactic sugar, we had to do something like, I don't know, like I mean, something like this, yeah. But it's actually doesn't work. But with some duplication, it would work. So this what it actually means in our code, that we want to execute. For example, this lines, what does it do? It actually collects some metrics for Prometheus in order to show them on this charts, yeah. And actually this function, it increments some metric. It actually shows how many connections we have in flight, how many ongoing connections do we have. So we increment some counter, and we want to decrement it when the whole function is completed. Yeah. So we increment it and instantly say that at the end of the function, no matter whether it's returned an error or returned somewhere else, we want it to be decremented. So this is just a syntactic sugar, or maybe just a function in Go language that allows us to perform this operation. The same with everything else here. Yeah.
So see on line 174, we've
174.
Yeah.
Like
so we've closed the Go function that started on line 171, but then we have this. We immediately have these parentheses. Does that? What does that indicate?
Yeah, it's actually like here or like here, because it's not defer here. Yeah. It's a bit different. It's a bit different code here. Yeah, it's not related to defer. Yeah. Okay,
sorry, we can move on. So thanks for the explanation.
It's just a way it's written in Go. That's why I say not to call this function at the end, but to call this block at the end. It's not called immediately. It's just the way we say to call cancel at the end of the execution. Something like this.
So it's a block with no parameters.
Oh yeah, something like this.
Okay. Right. Okay. Sorry for that segue, but yeah, thank you.
That's totally fine. Yeah. So let me recall where it is. So yeah, we've as far as I remember, we were talking about the sessions, yeah, and yeah. So when the session is handled, the session is we actually can process this types of comment, either the ones types of requests, the ones that describe us, that gives us that give us some information about the environment, and the one that contains actual comment. So yeah, let's talk about this block. This one is actually the block that handles this request. So when this comment is received by the server, these functions are called, and actually this function is called. And so we receive this comment. Maybe let me show how it looks. So when we send this comment to the server, we see that this comment is being executed, like executing the comment. And we can see the original comment, which is called gitlab-sshd. And so depends on which comment we have received, we create a structure which is defined here, structure of a particular type. It processes every type of a feature of a comment of an operation described here. For example, if we perform some LFS authentication via SSH command, then LFS authenticate object structure will be created. When we perform like git upload pack or git clone, this comment is created. Some more information regarding how it's implemented can be found in some other piece of documentation. I hope to have it merged like soon. But for every comment, we implement this comment interface, which has execute method. So so when we receive this comment, we create a comment of particular type and execute it. And yeah, for example, for git upload pack, execute method looks like this. It's just verifies access, actually performs this HTTP request to Rails, and verifies that the user is allowed to perform a particular operation, and then just let's keep this block, and then just performs a gitly call, which is a gRPC call. But maybe let's not elaborate what gRPC is in this session. Let's just assume that a request is performed to gitly, the data is the response is received from gitly, and the response is actually sent to a user. Yeah, that's probably it. Just some honorable mentions that our gitlab-sshd server, it supports proxy protocol. Proxy protocol is necessary for us to implement feature which is called group IP restriction. Proxy protocol allows to gain user real IP. For example, when gitlab.com is behind, gitlab.com is behind a load balancer, without proxy protocol, we receive an IP of a load balancer on gitlab-sshd. With proxy protocol, the real IP of a user is propagated. That's why we are able to implement this feature. So proxy protocol is just implemented using this open source package, and it's really implemented. It's really simply implemented. It's just wrapping our basic listener into a proxy protocol listener. Yeah. Some other things that we've also have implemented is some OpenSSH alternatives, or for example, an option that allows us to reduce the time allowed for user to authenticate. For example, if a connection, or if a user takes like more than 60 seconds to authenticate, then we just close the connection. It's like a security feature, just to avoid having a lot of idle unauthenticated SSH connections on GitLab.com. Like this feature, there's also a client alive interval that actually, when a server just sends keep alive messages to a client in order to keep them alive. In OpenSSH, it's called client alive interval, and yeah, we've implemented an alternative. And one important thing to mention is a state machine that we have on the server. Server actually implements a state machine and can be in this states. Why do we need it? In order to implement, for example, graceful shutdown. When a termination signal has been detected on the operation system, we shut down the server. When the server is shut down, when it's being shut down, it's we instantly change the status of the server to the on shutdown status. In this status, we stop accepting any new connection, and give a configurable grace period in order to ongoing connections to complete. So when this grace period expires, we just hard close all the ongoing connections. And yeah, also the state machine also allows us to implement liveness and readiness probes. Those probes helps Kubernetes. This has just endpoints. Let me show it here. Like these are just endpoints that they just tell Kubernetes whether about the state of our server. So when Kubernetes asks whether our server is alive, we return like 200 if the server is actually running. If when Kubernetes asks whether the server is ready to accept any new connections, if it's not being shut down, we send 200. If it's unavailable at the moment, we answer with 502. And yeah, that's all. Yeah, I'm sorry for all this complex information, but I plan to merge this documentation. I think it will be easier to just reading it and going over it by yourselves when you need it. Yeah. So thank you very much.
Yeah, that's great. I do have one question about authentication. Mm-hmm. So when we have rules defining who can push and pull and everything, so where in that flow do we actually check, if the user can actually pull? Does that happen like during the first authentication step?
So I would say that it happens on the second authentication step. I mean, here a handshake is performed. Yeah, when we perform the handshake, our SSH connection is established, we can just send wherever data or whatever we want, yeah. And then when actually a command is executed, we verify the access. Yeah, we actually perform this additional request and verify that a user is able to perform a particular action. So let me see where it's implemented. So it's implemented in access verify model, and so it's implemented in a different package like this one, and allowed request is performed. Yeah, after connection is established, yeah, we are ready to execute a particular function. Then we verify that a particular user is able to perform this, is allowed to perform this operation. Yeah.
Okay. Igor, I've got a follow-up question to Joe's question. If you could just go back to the architectural diagram.
Sure.
So when you say handshake, so what we mean is the first call when we're looking at authorized keys is we're just checking whether their SSH key is valid, right? And then and then if that's okay, then the second call is then we check, are they authorized for this repo or whatever?
Yeah, that's actually makes me think that in this diagram it would be cool to have like a quick note where handshake is completed. Yeah, so it's somewhere here, I would say. Like it would be cool to have this line to separate that handshake is completed, SSH connection is established, and then some GitLab specific part is started being performed. Yeah.
And then, sorry, I don't want to ask all the questions. So if someone else has a question,
no, that's
I've got more to ask, but
yeah,
I'll open the floor.
I think if you have questions, I think you should ask them, and we can discuss it. Yeah.
Does this currently only support Git actions towards GitLab, or do we also use this for SSHing into like the CI?
So actually, let me think. Maybe I don't know which commands do we have on CI that are performed. Oh, so yeah, let me just show. Or maybe could you please elaborate what do you mean by SSH actions on CI? Yeah,
like you can SSH into a CI pipeline and debug it, right? So we had this issue where customers were unable to allow a range of IPs. So I'm just wondering if that exists in RCI as well when you SSH in to debug it.
So I think CI boxes instances, they have like let's say different architecture. I think a simple OpenSSH is used there, but I can't be sure. Yeah, but exactly this gitlab-sshd is just like SSH server restricted to our particular use. It just supports our features that are listed. Yeah, I already showed them. So that I mean, like git clone, git push. So when we deploy GitLab, then we have this SSHD server that is only used for our GitLab specific commands. But for SSHing to the box, to the instance, I think it's not allowed in gitlab-sshd, also due to security reasons. And yeah, I think on instances it's implemented with OpenSSH, but I can't be sure. Yeah.
So Igor, I think this is also this is clear on the diagram. I just want to kind of call it out. So so all the activities that GitLab SSHD are performing are basically around authentication, and then once the user is fully authenticated, both via keys and then via their their actions, then we actually see this unload pack request that's going directly to Gitly. And at this point, there's no more traffic through GitLab SSHD. It's Gitly replying directly to the Git client. Is that correct?
I would say it's just let me probably show. Maybe it won't explain it a lot, but we actually providing a channel to Gitly. We're actually providing like an abstraction to Gitly, something that Gitly can write into. Before gitlab-sshd, it was just std out, because OpenSSH was reading from std out. But now with gitlab-sshd, we provide channels. We provide channels. These are gitlab-sshd abstractions. It's something Gitly can write into. So we just give Gitly the abstractions to write the data into it, and we also propagate this data to the user.
And so, because we've developed those channels, does that mean those channels are also instrumented and monitored by our code?
They can be. They actually these are the abstractions provided by SSH library, Golang SSH library. But if we want to monitor them or extend them, it's actually possible, because like read writer it accepts not a specific type or something like this. It's accepts an interface, writer, reader, and these interfaces, they actually just implement write and read functions. If we want, we can like override them and, for example, monitor all the data that comes through these functions if we need it, actually. Yeah.
So if during the Gitly, the Gitly is downloading data and suddenly something happens, right? Gitly goes offline or the network's down or something. Does GitLab SSHD capture that error and report back to the client, or does it we just drop the connection?
So if it's actually
like if we lose the we lose the network connection to Gitly, for example.
For example, yeah, if we have a problem with an issue with Gitly, this command actually returns an error. Yeah, and in this case, this error is propagated like higher. So let me just show the final code, and then we just capture this error, and we track it. Currently, I'm showing the place where we track this error in order to show them, in order to take them into account on this chart.
But
your question was different, and
it's kind of related actually. So we are, I guess, but
in this function we just return the message to the user that with the reason why this particular connection was interrupted.
So even if there's an error in the Gitly, we catch it. GitLab SSH catches it. Okay. Yeah. Great. Anyone else with questions? I just want to also point out to everyone that we still do have OpenSSH, and correct me if I'm wrong here, Igor, in the same code base, and we're keeping it because we originally did not intend to keep it, but for FIPS support, we need to keep it. So we actually have both sets of code in the same binary. Is that correct, Igor?
So it's maybe...
It was two separate binaries.
Yeah, it's multiple like binaries that we have. Just a second. So we have multiple ones. Yeah, gitlab-sshd is responsible for the server. This binary is responsible for processing all the connections provided by OpenSSHD, and that's true. We still have like two options: either our previous approach or this one. And the previous approach actually by default on self-hosted applications, and yeah, due to the FIPS concerns, we also decided to leave OpenSSH because it's like battle tested and FIPS approved. And FIPS, it's actually just a standard for a cryptographic standard, yeah, for that we are trying to pass. Yeah, so we have this architecture available as well, and some users actually not yet sure whether they want gitlab-sshd on their self-hosted applications, because we have like this comments here. Oh yeah, was wrong. It was fixed. Yeah, yeah, I believe. So yeah.
Any other questions? In that case, I'll ask the last question, which is, for example, if any of the other team members were interested in contributing to this project, do we have any low-hanging issues that you know, would be, you know, low entry issues that someone might be able to look at in our backlog?
So those issues can be found like here, yeah. But do
we have a label?
No, I think we don't have a label yet. Yeah, okay. But it's something, yeah, to have a look at the issues list. And maybe I would even mention that don't be afraid to take something more complex that's just simple, because quite recently I've noted that we have an open source contribution to support like Kerberos on for gitlab-sshd. So some complex stuff can be done as well. So yeah, we have issues list, but yeah, also complex stuff can be done. Yeah,
Igor, that was awesome. Thank you so much. I'm looking forward to seeing the documentation merged. It looks really great. It's I think for a long time that project hasn't been well documented, so you've explained everything very clearly, I thought. And yeah, great job.
Thank you very much. You're very welcome.
I'll stop the recording.